In this video, I'm going to be covering how the rate of reaction can apply to a reaction mechanism where an overall reaction can proceed in three elementary steps like this one. So not every reaction will proceed in one step. So how do we determine the rate of reaction when an overall reaction proceeds in more than one step? So one thing we need to keep in mind is the topic of rate determining step. So the analogy I like to make to describe rate determining step is making a cheeseburger. So if you were trying to make a cheeseburger and you were going to put one person in charge of doing each thing to make that cheeseburger, what would happen? Well, you would need someone to have the buns ready for everything that's going to go on that cheeseburger. You would need someone with lettuce prepared, someone with a tomato, and then someone cooking the cheeseburger. So the person with the buns, that will not take a long time. All they need to do is take it out of the package. The lettuce, someone needs to just chop one slice of lettuce and have that ready. The tomato is already sliced, so the person just takes it out of the package. All three of those jobs are very quick. Now, what all those people are going to be waiting on is the person that is actually cooking the cheeseburger. So you cannot serve the cheeseburger until all the steps are done, and you are only as fast as making that cheeseburger as your slowest step is. So even though the other steps are pretty fast, you don't have a cheeseburger until that slowest step is complete. The same thing is true for a reaction. If one of these steps proceeds fast and one of them proceeds slow, the reaction will not be complete until that slowest step is complete. That slow step, or the slowest step of a reaction mechanism, is your rate determining step, meaning it determines the rate because the reaction will be waiting on that slow step in order to proceed. So what we can do, maybe this step of the reaction is fast. Maybe this one also proceeds fast. So A going to B happens quite quickly. B going to C is also pretty fast, but maybe this last step, C converting to D, is our slowest step. This step right here will be our rate determining step because it is the slowest step. So this reaction cannot be complete until C is fully converted to D in the slow step or rate determining step of a reaction. So just as an overall summary, you cannot determine the rate of a reaction based on a fast step. You can only determine it based on its slowest step.